Alrighty, welcome to Rationalizing the Denominator. Alright, so what's all this Greek talking about here? Okay, so, it sounds like some foreign language. First of all, denominator is this guy. Okay, it means your expression on the bottom when you're dealing with fractions. And right now, the square root of 2 is an irrational number. Okay, irrational number. And that's not very good. We would like to rationalize it. Now, rational numbers, what are we talking about? Well, rational numbers are numbers like 2 or -3. Nice numbers. The numbers typically that people like to work with. Okay, maybe not -3, but certainly 2, numbers like that. So I'm going to show you a process here of how we would do this. Now, this is about as easy as these are going to get when you just have a single irrational number or expression on the bottom. So what we do is we multiply it, in this case, by the same thing. Okay? The square root of 2 times the square root of 2. Now, with fractions, you don't want to change the fractions. So whatever I do to the bottom, I have to do exactly the same thing on the top. So on the top, I'm going to get 2 times the square root of 2. All right, so okay, there it is. On the bottom, I get the square root of 2 times the square root of 2, which is the square root of 4, which is actually just 2, which is a nice rational number. And look at this. This really is a nice one, because look at the 2 cancels with the 2 on the bottom, and this whole thing equals root 2. It's not even a fraction anymore. It doesn't get better than that. So technically speaking, if you wanted to, you could think of it, yes, it does have it's still a fraction if you like, and the number on the bottom is a rational number. Very nice. All right, so let's blast through a few more examples. I'm going to clear the page here. And then we're going to show you, in some cases, they can get a little more complicated. We'll show you what we do with that. Okay, so we have 5 root 3 as a numerator, and 6 root 5 as our denominator. Now this is an irrational denominator, so I want to rationalize it. So I'm going to multiply the top and bottom by, what do we got here that's irrational? Root 5. Okay, now you notice that I didn't really care about the 6. The 6 is fine. It's a rational number. I don't need to do any, I don't have to try to change that one. I just got to target this guy. That's the troublemaker. So when I multiply the bottom stuff together, there's my 6 still sitting there, and I got root 5 times root 5, which is root 25, or just 5. On the top, I have 5 times the square root of 3 times the square root of 5, which is square root of 15. Okay, so what do I got now? I got 5 times root 15, and on the bottom, I have 6 times 5, or 30. Hey, actually, I could have just canceled the 5s here, couldn't I? That would have been smarter. Anyway, I can still do that. And so I got root 15 over 6. And there it is. Beautiful, nice, rational kind of numbers. All right, let's see if we can squeeze in another example over here. 4 on the top. And what a mess on the bottom. We got the cube root of 2x squared. So we got to deal with this thing now. Okay, we're trying to make the bottom so that we really don't have a radical anymore. So I'm going to have to multiply by something that when I'm stuck with cube roots, first of all. Let's be clear on that. Whatever I multiply by has to be a cube root, because if I'm going to multiply this by another cube root, then they both got to be cube roots. And now I got to try and come up with stuff that will ultimately not have a radical left with it. So I got a 2 over here. What I actually need is a couple more 2's, right? If we're talking cube roots, I need 3 of them in order to get them out from being under the radical. So I need 2 more of them. So I got to do the same thing up here. Now I already got 2 x's, so all I got to do is chuck another x in there. That should do the trick. So let's just see if it actually works. So the top, well, there's not much I can do with the top. I'm going to have basically, I could call the 2 squared a 4, I guess. That makes it look a little neater. But here's the big thing. Did I do it right? Let's see what we get on the bottom. I got a 2 times 2 more 2s. So that's actually an 8. And I got an x squared times an x, so there's 3 of them. Okay, so I think we did the right thing. We got this stuff on the top. Okay, and then on the bottom here, the cube root of 8 is a 2, and the cube root of this x cubed is an x. All right, pretty much there. One more little thing I can do. I can divide this 2 into the 4, and it goes in there twice. So let's just rewrite it so it's nice and clear. Here's what we got. 2 times the cube root of 4x all over x. Well, isn't that lovely? It sure is. Okay, now let's move on to the next animal here. And the next animal here looks like this. What if you have a fraction and you have something on the bottom that is an irrational number, but it's not just one term? What if you got something like this? Okay. Whenever you run into this, where you have like 2 terms and they're linked with a plus or a minus, the only way to rationalize it, okay, is to multiply this guy here, which is the whole thing, by something we call its conjugate. And again, we've got to do the same thing on the top. Okay, now the conjugate is the same terms, so I want a 5 and I want a root 2. Okay, but instead of having a minus root 2, you got to switch it. You got to make this one the opposite. So here I have them as pluses. Now I'll show you why this works. Okay, first of all, on the top you got 1 times this stuff, so it's basically this stuff. Okay, but on the bottom, okay, I got to kind of FOIL this mess out. So I'm going to have 5 times 5, so that's 25. Then I've got 5 times positive root 2. So that's a positive 5 root 2. And I've got a negative 2, root 2 times 5. Okay, so I'm going to have a negative 5 root 2. And then finally, I've got negative root 2 times positive root 2, which is a negative root 4, or just a 2. Now, what's good about this is that the top stays just the way it looks, no problem there. On the bottom, I got a positive 5 root 2 and a negative 5 root 2. These guys kind of kill each other off. They add up to nothing. So I'm left with 25 minus 2, which is 23. And that's a nice rational number that I have on the bottom. Okay, I got one last example to show you, and then we're going to stop. So let's have a look at one more of those. So here we have 1 minus the square root of x on the top, and on the bottom I have 3 plus the square root of x. And our job is to rationalize the denominators. Okay, so I'm going to use the conjugate. Because there's more than one term on the bottom, I'm going to multiply the top and bottom by the conjugate. Okay, notice what I'm doing here. It's the same terms, but instead of plus, this time it's using minus. Okay, so what's going to happen? Well, you got to FOIL out the whole top and the whole bottom. But you can save yourself a bit of work. The more you get practiced at this, you know, you're not having to write every step. Because here, 3 times 3, okay, that's 9. Now, I'm not going to write 3 times negative root x, because I know it's going to cancel with positive root x times 3. Why write them down? I know they're going to, that's the whole idea of the conjugate, is that they're going to wipe each other out. Then I got a positive root x times a negative root x, which is negative x. Okay, so there we go. That one's all worked out. Now we've got to work out the top. 1 times 3 is 3. Now here, I don't think things are necessarily going to cancel, so I'm going to write it all out. 1 times negative root x, that's a negative root x. Then we have negative root x times 3, so that's negative 3 root x. And finally, negative root x times negative root x is positive x. So we can combine these two guys in the middle because they're like radicals. So we're going to have minus 1 and minus 3 makes minus 4 of these guys. And then we have the plus x. And then all of that is over 9 minus x. And I got to put one little disclaimer in here. I want x to always be greater than or equal to 0. And that's because here I'm trying to square root this x, right? That's actually all the way through. I'm trying to square root x, which has to be a positive number. So that's where I'm going to stop, and we'll talk to you a little later on.